I was asked about how to do lab activity exercise 1711, so I'm going to try to provide you with a short tutorial here on how to do the problems for that. The top chart here, to make a determination as to what type of climate the data represents, we use the flow chart here. We'll start off by making the determination of whether or not it's an E climate. And the E climates are probably the easiest to determine because you're going to be looking for cold temperatures for most of the year. And that would be the case for station 4 here, where we've got all these negatives. But when you get beyond that, it gets a little bit more challenging. So the next step on the flow chart here is to determine if it is a B climate. For that, it reads, is the station a B climate? To determine this, select the proper formula from the 3 listed with the B climates on figure 17.4. And 17.4, that is what is down here. Okay, so now let's consider the formulas in here. R is the average annual precipitation in centimeters, and T is the average annual temperature in Celsius. When R is less than the calculated value, then the climate is dry. And then we have 3 options there. So one is when, the first one, R is less than 2 times T plus 28. That's this one here. When 70% or more of the rain falls in the warm months, those warm months being April through September. The second one, R is less than 2 times T when most of the rain is falling in the cooler months. And then the final one is when neither half of the year has more than 70% of the rain, so the rain is a little more evenly distributed over the course of the year. I'm just going to look at my data in the table from the 8 stations, and it seems to me that the one that is most clearly a dry climate is this one here, station 8. It has the least amount of precipitation at only 77 millimeters for the entire year. And while it is drier in April, May, and June than July and August, September, you get a fair amount of rain there, and then there's also a fair amount of rain in the cooler months as well. So it seems like it's pretty even over the course of the year. So I'm going to use that third equation. R is less than 2 times T plus 14. So R equals 77 millimeters, but the formula asks for it to be in centimeters, so I'm going to convert that to centimeters. There are 10 millimeters per 1 centimeter, or 1 centimeter is equivalent to 10 millimeters. I'm going to cancel out my millimeters, multiply. 77 times 1 is 77 centimeters, divided by 10. 10 into 77 will be 7.7 centimeters. That's my R value, 7.7, which, going back to the formula, is going to be, let's see if it's going to be less than 2 times the average temperature, which is 23, and then that will be multiplied plus 14. 7.7 is less than 2 times 23, which will be 46 plus 14, and that equals 60. So is 7.7 less than 60? Yes, it is. Therefore, this would equal a dry